Ladies and gentlemen, let's look at today's Leetcode daily, number 76, minimum window substring. In this problem, we are given two strings. The first is S, the second is T. So in the test case, T is A, B, C, and S is this big one. So we are going to find a substring such that the substring is a superset of T. So what is a set? A set is a bag of characters, and we do not care about the orders of those characters. And what is a subset? If we remove any number of from this set, we will have a subset of the original set. So let's look at this substring. If we view this as a set, then we can remove some characters to form a new subset. So here we have A, B, and C, and some other characters. If we remove those other characters, we will have the subset A, B, and C. So this subset A, B, C will be equal to the subset of T because T is 1A, 1B, and 1C. Now this question asked us to find a substring. Here it is, from the original string. We can see that for each of the substrings, they will have start and end. We will call the start point the left pointer and the end point right pointer. Now this becomes a two-pointer problem. We know that in a two-pointer problem, we can move the pointers to make the window bigger and smaller. Here we will move all the two pointers right forward, meaning that if I move the end pointer right forward, the window will be bigger. But if I move the left pointer right forward, the window will be smaller. When the window becomes bigger and bigger, it's more likely the window will be valid, because we are going to need some characters, right? If we have more and more characters, we are more likely to be the superset of this set. But if the window is becoming smaller and smaller, we are less likely to be valid. Here, I have a counter to check if the substring is valid. Now we can see from the start point, the substring is just empty here. So we will need 1A, 1B, and 1C. As long as our needs are not satisfied, we can see that the substring is not valid. When the window becomes bigger and bigger, the needs, the A, B, C, will be smaller and smaller, and the needs will be satisfied. When all the needs are satisfied, the substring is valid. Now let's look at the animation. So at the very beginning, we do not have any characters, and we still need 1A, 1B, and 1C. Now let's move forward. Now our left and right pointer, they both point to index 0, and index 0 is A. So we will decrease A in the counter. Now because A is now 0, we no longer need an A, but we still need a B and a C. So we'll enlarge the window. Now we have a B. B is 0. And now we have a C. So we no longer need a C. So this is our first valid answer. Go back. Now this window is valid. We'll try to shrink it to see if it will be valid after shrinking. Now let's shrink the first character A. Because we have dropped an A, so that we now still need an A. Because we need an A, so that's why this substring becomes invalid. As these circumstances, we will move our right pointer right forward, looking for an A to make the substring or the moving window valid. So let's move. Now we have an additional B, right? This is an additional B. So this becomes -1. Now we have an A. It's valid again. Because this is valid, we'll try to shrink it. Shrink. See, we are going to drop a B from this window, but it will still be valid because previously we have make this -1, right? Because we have additional B's. So once we drop the B will still be satisfied, because we are just dropping the additional B's. See, this is still valid. So this is valid, but the length is still 6. Now let's move forward. Now a C is dropped. We still need a C. We'll try to find a C. Here it is. This is C. Now we'll shrink it, shrink, and we'll have our best answer, bank. If we shrink more, this will be invalid. Okay, let's look at the code. Here, this is the code, and I think I'll only talk about this variable. It's called need all. Need all is the summation of the need list. This is the need list. So that's why at the beginning, need all will be the length of t. And once one number is dropped from a positive number, need will be dropped too. Because previously we need an A, now we no longer need an A. That's why need becomes 2 from 3. And once one character is dropped, like this character, once this character is dropped, our need will increase. Maybe this will increase from a positive number or 0 or a number below 0. Here is now A is dropped and we will need an A. That's why A is increased to a positive number. Because the new number is positive, here it is, we can see because the new number is positive, so that's why we can see that we now have a new valid genuine need of an A. That's why now we can see that need all is increased. Sometimes this number can be minus. Let's see. Here it is. This number is minus. At these circumstances, when a B is dropped, our need all will still be the same because because at this stage we don't need any characters, and at this stage we still don't need any characters, right? Because we have additional A's, so that's why the count. I'm sorry, we have additional bits. That's why our count for B is -1. Now our count for B, our needs for B is 0, meaning that we still don't need bits. At this time, need all will not be changed. O2C, need all is always above 0. When need all is 0, need all is always greater than or equal to 0. When need all is 0, then we can see the substring is valid, otherwise it's invalid.